Welcome to 558 Parkside Tech, where we talk about tech, and of course, more tech. I'm your tech plug Mike, and today we're talking about packaging software. You see, prior to 2014, everyone just pretty much rolled to a VM, and that's how they handle performance. But things have changed. Since 2014, containerization has existed, and many companies are switching to that. So let's talk about that today. In the words of Zig Ziglar, you don't have to be great to start, but you have to start to be great. So I'll see you at work right after this.
Yeah, 558 Parkside Tech in effect, 558 Parkside Tech in effect, tap in the future. Let me introduce you. 558 Parkside Tech, about to school ya. 558 Parkside Tech in effect, 558 Parkside Tech in effect, 558 Parkside Tech in effect,
Parkside.
Today we're talking about Docker containers. And hopefully when we walk away from this conversation, each person should be able to answer three questions. Three questions that I say in all my other videos, a person should be able to answer. That is, what is it? What problem does it solve? And when do I use containers? So let's get into that. Now, how we're going to cover it is we're going to first get into VMs. If you haven't seen my previous video on VMs, please go back and grab one of my previous video on VMs so you can understand what a hypervisor is and what happens when you create virtualization using VMs. You're also going to review the container for Docker and get more into that. And then we're going to do a comparison between VM and a container. And finally, we'll do a recap and some takeaways. So let's start off with VMs, okay? Most people don't say virtual machine, we just say short. If you're in tech, we just say VMs. You know how we like our acronym. So now with the VM, we're really talking about hardware virtualization, okay? Virtualization of our physical hardware. So here I have a physical hardware device, but I'm able to, with some software called hypervisor, create multiple virtual machines within that physical hardware. And they will share all the resources of that physical hardware. In this case, I'm creating a database and I'm creating an email application, whereas my database is using Unix and my app is actually using Linux. Okay, so both of them are using two different operating systems. And then you also have the physical machine, which has its own operating system. Each of these think they're standalone and running by themselves. They have no idea. So the app doesn't know that the database is there. Linux doesn't know that Unix is there. That's the beauty of hardware virtualization. Now, as we start to talk about Docker and Docker containers, we find that a guy named Solomon Heights created Docker in around 2013, 2014, when he worked for a company called .cloud. But Linux containers, the containers that we're talking about, have been around since 1999. And that's what Docker containers are based on. Docker open source technology got popular when it got more involved with Git technology. If you haven't watched my video on Git, if you don't understand what that is, please do go and watch that. And once they got involved with that, then this Docker technology or containerization became very popular. An example of that, if you're using GitHub and using a GitHub action as part of your workflow, you can automate containers in a flash. Now here's an example of a Docker container. But in this case, we're isolating a process. Remember now in VM, it was hardware isolation or virtualization. In this case, it's process isolation or virtualization. You can run multiple containers on a physical server. What makes that possible is a Docker kernel or Docker engine running on this physical machine. We still have layer 1 and layer 2 technologies. That doesn't go away. But here's the key. They all share the same host OS, which is different than VM. I want you to keep that in mind. But most importantly, understand this is process isolation, or another way to put it, this is applications. This is multiple applications being containerized, being able to run on a single server. Now here's an example side by side of what the two would look like visually, right? On the left, we have a container, which we just shared with you or just laid out for you that it's process isolation. And here we have multiple containers. We have the Docker engine there, and we have a single OS running. And all these containers share that same OS, which makes it very lightweight. Containers are very lightweight. Please walk away with that understanding. Whereas with VMs, it's hardware virtualization. And in this case, I'm showing you that there are 3 different machines being housed here. And what makes them work is a hypervisor. But the difference is each one of them has their own OS system, own operating system. And that's what makes them so different and a lot heavier than what you see when you're dealing with containers. Now, I made a note at the bottom here about Docker images. So I'm just going to throw this out, but I'm going to talk about it a little bit later in this discussion. A Docker image is a read-only template that gives you instructions for creating a container. That's important. I get many emails with confusion about the difference between a Docker image and a Docker container. The Docker image is just like an instructions that you get in a box when you get furniture. So think of it that way. Now, if you're going to do anything with Docker, I would suggest that you go to Docker Hub and sign up. Here's the problem. If you're at work and you're trying to learn about this technology, 9 times out of 10, you won't be able to download it onto your work machine. And since you can't, there's a solution I'm going to have for you in a second. But first, let me give you the flow of it. So here, imagine you have an application. Let's say you're home and you wrote something, or you're at work and you wrote something. You would then build a Docker image, which is step 2. So you took your source code. Another way to say that would be your application code, and you copied it to number 2. You built a Docker image. Then you register it with the Docker registry, and it's just there. Now, whenever you want to run it, you pull it from the registry and you run your application. A Docker image looks similar to this. These are some of the things that are in a Docker image, or the instructions for how to create a container. You have a copy of your code, you have the work directories, you have run, npm install, you have your entry points, and I'll show you this more in part 2 where we actually create a container from an application. Usually a Docker image is about 5 megabytes in size, very small. Here again, if you were to go to docker.com, you will find documentation that I think will be useful as you're learning more about containerization. Here's the thing I mentioned earlier. Since your company won't let you download Docker software onto your computer, you can log into labsplaywithdocker.com. But in order to do that, you must have a Docker Hub account. So do that first. Register with Docker Hub first. All right, that way you can put a registry on there. You can create an image, okay? So here, when you do Play with Docker and you log in with your Docker Hub account, it will give you 4 hours of playtime. You can create containers, you can do anything you want. You have 4 hours to do it, and you don't have to worry about cleaning it up. It'll automatically delete it for you. Now, some of your Docker commands are pretty straightforward. We have a Docker build, which creates an image from a Docker file. You have Docker images, which list all the available images on your system. You have Docker run, which launches a new container from an image. You have the listing of all running containers with the PS. You have the stop when you want to stop a container. You have RM for removing a stop container from a system. You have RMI, removing an image from the system. You have login, which obviously is logging into a Docker registry where your image is stored. You also have push, which is pushing an image to a Docker registry. I won't read the rest. You can figure it out for yourself. There are a limited number of commands. It's not a lot of commands when dealing with Docker. So now, what is the Docker Hub? As a reminder, it's the cloud service that provides registry and repository service for a Docker image. A Docker engine, which has to sit on a server, is the runtime environment for a container. What I mean by that is if you want to put your container on a server, as long as it has a Docker image, it'll run. Docker command line is kind of the CI for your Docker engine. And those are the commands that I showed you in the previous slide. Now, containers are portable, scalable, but to scale them, you would need orchestration tools like Docker Swarm, Kubernetes. There's also OpenShift. There are a few other orchestrations of containers that you can use. Now, the OS is the whole point of using Docker containers in contrast to VMs, is that they use the same kernel. That's so important that you understand that. And obviously the Docker Hub is a service that provides registry and repository services for your Docker image. Let's do a quick recap. Both containers and VMs are virtualization. A Docker image is a read-only template with instructions for creating a Docker container. A container is process isolation, where all your libraries that you need, your scripts, your environment, your variables, your configurations are all there to run your application. We also outlined that VM is hardware virtualization, where each VM has its own OS. That's what makes VMs heavy. The other reason why many are moving from VMs is the blue-green concept for switching isn't flexible. And if you're using that in your company, you should already know that it can give you a few headaches. Deployment apps can only run on a comparable OS. What does that mean? That means as I'm moving my VM from one machine to the next, my VM or my application is using Linux. On that other machine, there better be Linux. Whereas with a container, you just have to have the Docker image. It can run anywhere. To control the container, you can use the Docker UI, or you can use the Docker CLI, which is the commands that I showed you earlier. I made a note here that if you want to get started, you need to sign up with Docker Hub, and you can play at work or anywhere using Play with Docker, which will give you 4 hours of creating a Docker container and playing around with the commands and so forth. Runtime Docker pulls images from the image registry to create a container, manage storage, networking, and interact with other containers. I made a footnote here, but I've outlined this already. Hope you now have a better understanding of containerization, or more directly, Docker containerization. Because there are other containerizations that you can get into. There's Docker Swarm, there's Elastic, there's OpenShift. There are many more, but the concept is pretty much the same. As always, be better than your best excuse and learn tech. And if someone tells you you're doing too much, you tell them they're not doing enough. All right, hit the like button. I'll see you soon. Peace.